Hello there, my name is Dean Wells. I'm a program manager in the Windows Server Assurance team.
And I'm Ryan Puffer, a program manager on the same team.
Today we're going to talk to you about shielded virtual machines and something we call a guarded fabric. So if you take a look at the slide here, we've given you a little bit of a definition of what a guarded fabric is. Essentially, it protects tenant workloads, the shielded virtual machines, from inspection, theft and tampering by either malware running on the host or from admins themselves. So what are the requirements then to actually deploy a guarded fabric? Let's go through a little checkbox list here. We need a place to run shielded VMs that's free from malicious software. Of course, this is essential because if the place where you're running the shielded VMs has malware running on it, then the defenses are very, very questionable. So we have to ensure that the code integrity on the system is up to scratch. We need a way to verify then that that host is in that healthy state. We need a process that securely releases keys and only does so to healthy hosts. And we need management tools to automate the provisioning of shielded virtual machines to ensure that people don't tamper with the template disks, for example. So here comes a new term, guarded host. Obviously, a guarded fabric is comprised of guarded hosts. So what exactly is a guarded host? Well, it requires Windows Server 2016 Data Center Edition. That's the only edition that can run shielded virtual machines. And we have an external service, an external authority known as the Host Guardian Service that we'll talk about in a second, that is able to prove that those 2016 Hyper-V hosts are running in a healthy mode, a mode that has been measured by the Host Guardian Service. Now, exactly what does the Host Guardian Service do? Well, it provides two functions. One of them is attestation. This is the part where we measure the health of a given host. I'll talk specifically about what things are measured in a second. The other thing that it does is this key protection and key release, whereby we give keys back to healthy hosts. There are 2 or 3 optional components that you can tack onto a guarded fabric. These are not required, so I do want to be clear there. You can use System Center Virtual Machine Manager. I would recommend that this is used because VMM provides a great deal of additional management tooling than you would get merely with the PowerShell commandlets themselves that come with Hyper-V and that come with the guarded fabric workloads. The Service Provider Foundation, otherwise known as SPF, this is, it's a technical term, it's an API that sits between Azure Pack and VMM and allows Azure Pack to provide a nice graphical web interface to manage a guarded fabric of shielded VMs. Last but not least, Active Directory, it's typically going to be present, but it can perform a couple of roles. Active Directory itself can be running on the Host Guardian service, and it can create its own Active Directory forest for its own security purposes, for management and obviously for cluster authentication, those kind of things. Or you can use your own Active Directory forest if you have a suitable one, and we'll talk more about that in a second. So, how do we get from a regular fabric running on, say, Windows Server 2012 R2 to a Windows Server 2016 guarded fabric? Let me sort of walk you through. If you start with a 2012 R2 fabric, how do you get to Server 2016 and a guarded fabric? Well, here we are. If we take a look on screen here, I've got my contoso.com domain, I've got Hyper-V host inside it, and we've got VMM in this particular scenario. So, step 1 in building a guarded fabric is obviously upgrade the Hyper-V hosts to Windows Server 2016, and I'll emphasize again, Data Center Edition is the only one that can run shielded virtual machines with a Host Guardian service attesting to health and providing key release. What is step 2 then? Step 2 in building a guarded fabric is, again, fairly obvious. We have to deploy this thing we've been referring to as the Host Guardian service, or more briefly referred to as HGS. This is the thing that does the health attestation. It can measure whether a Hyper-V host is healthy or not according to a predetermined set of instructions, a baseline, if you will, that's added to an inventory database that the Host Guardian service preserves. So step 1, just to recall here, was upgrade the hosts to Server 2016 Data Center Edition. Step 2 is install the Host Guardian service and configure the Hyper-V hosts to use it. Step 3, not particularly difficult here either. Step 3 is extract the identities, this baseline that we've been referring to, the hardware baseline, and last but not least, a code integrity policy. So let's just pause there. The first thing that we need is this identity. This is to ensure that the Hyper-V host is actually allowed to participate in the guarded fabric. The second thing that we need is this hardware baseline, a good technical term here for you. Effectively, what we're taking from the Hyper-V host is something called a TCG log, or a trustworthy computing group log file, which contains all of the things that the host did from the UEFI firmware right the way up through the kernel and all the way to the point where the host is entirely booted. We measure those things, a trusted admin extracts them, and then they get added to an inventory database on HGS. Last but not least, a code integrity policy. Windows Server 2016 and Windows 10 both have a new form of enforcement for code integrity policies referred to as HVCI, or Hypervisor-enforced Code Integrity. This is a very, very strong, very capable method of ensuring that a host is only allowed to run binaries that a trustworthy admin has allowed it to run. We wrap all those instructions up in a CI policy, and the host guardian service measures that code integrity policy to ensure that it's in force. All right, next step then. Well, effectively at this point, the guarded fabric is complete. We have guarded hosts. We can now run shielded virtual machines if we so choose. We could go and say, let's install Azure Pack, and obviously that brings SQL in, if FCVMM is there, and SPF that you saw earlier. But at that bare minimum, we have enough to deploy shielded virtual machines. So let's talk a little bit more then about the host guardian service. Here's a kind of succinct definition of it. It's an external authority that we use to guarantee the health of Hyper-V hosts when trying to run or live migrate shielded virtual machines. That's its role in life. There are two modes, two means by which we can measure the health of a host, and these are mutually exclusive. You cannot do both, you can only do one, and you choose it at the time of deployment, or you can deploy in the easier to adopt mode, which I'll talk more about in a second, and then transition to the harder but stronger enforcement mode later. So let's talk first about the strongest of those two modes. We refer to it as TPM trusted mode or hardware trusted. Measured boot is required, so we're talking about UEFI firmware here with secure measured boot capabilities, and that in turn brings a requirement for a TPM. I do want to be very specific on this point. We only support TPM v2. Only Trusted Platform Module version 2 are supported for TPM attestation mode Hyper-V hosts. TPM 1.2 is not supported in this mode on the Hyper-V host itself. So we've said that if we're going to deploy TPM trusted mode, that's our form of attestation, we're going to require a TPM v2 and we need UEFI secure measured boot capabilities. We must have code integrity enforcement as well in this. This mode obviously measures the health of the host both in terms of what did it load when it booted and in terms of its code integrity policy, which dictates what admin tooling can be run once it has booted, i.e. what can an administrator do, what sort of binaries can they run, what PowerShell commands are they allowed to use. And last but not least, we have to have some very strong form of identification from that host. Now, you could argue that Active Directory domain join would be a sufficient form of identity. In this sort of guarded fabric, we're asserting that that isn't a strong enough identifier. We're asserting that we need something a bit stronger. That identifier is referred to as an EK pub, or, better stated, an endorsement key, the public copy of it, from the TPM that the Hyper-V host is using, that TPM v2. So the identity is the EK pub of the TPM v2 that runs on the Hyper-V host. We then also obviously extract that baseline, which is the TCG log, all of the things that it did from the UEFI firmware right the way up to the point where it was booted and you could log on. And last but not least, the code integrity policy is measured, and typically it would be enforced using Hypervisor-enforced Code Integrity. The second of the attestation modes, and this is the one that is far easier to adopt because it does not mandate TPM v2. It doesn't require a TPM of any kind. You can have a TPM 1.2 in the Hyper-V host for BitLocker purposes if you want to secure the disks. That's a good idea. More security typically equals better. But in the case of the admin trusted mode, what we're effectively saying is we're going to use Active Directory identity to determine whether this is a blessed host or not. We're going to measure nothing to do with what it booted and nothing to do with the code integrity policy. We are merely going to measure its membership within a group. So why would you choose admin trusted attestation over TPM trusted attestation? Well, imagine if you are doing exactly what I've been saying we're doing here. You've got a 2012 R2 Hyper-V fabric and you want to upgrade it to a guarded fabric. You've got existing Hyper-V hosts, and it's very unlikely that those Hyper-V hosts would have TPM v2 in them at this point in time. TPM v2 really only became dominant or available and popular somewhere around December of 2015. Your hosts may have it, but most will not. So typically what we would recommend is upgrade that 2012 R2 fabric to Server 2016 Data Center Edition. You can deploy it as a guarded fabric with the host guardian service using this admin trusted mode, which uses Active Directory domain join identities and measures your membership in a blessed group to determine whether a host is healthy. If it's in the group, it's deemed healthy and can run shielded virtual machines. If it's not in the Active Directory group, it is deemed unhealthy and it is not permitted to run shielded virtual machines. But of course, while this may well offer the technologies that secure the virtual machines themselves, such as a TPM, a synthetic TPM gets projected into the virtual machine, it can use UEFI secure boot of its own accord, its own UEFI firmware, and it can use BitLocker, backed by that synthetic or VTPM, to secure its own encrypted disks. All of those features are common to both attestation modes. But with TPM trusted, if a malicious admin or malware running on the host attempts to attack a shielded virtual machine, it won't be able to do so because it doesn't comply with the code integrity policy. If you are using admin trusted mode, the shielded virtual machines are protected to a point, but I can run any software of my choosing. I could install a rootkit and reboot the Hyper-V host. That did not change its membership in the blessed group. Subsequently, a Hyper-V host that's running as a guarded host, that's a member of the blessed Active Directory group, that now has a rootkit on it, is still allowed to run shielded virtual machines. That would not be possible with the TPM trusted mode because the boot measurements would have changed and we would refuse to hand out the keys and the health certificate, which is the job of the Host Guardian Services attestation capability. So as I mentioned earlier, if you do already have a 2012 R2 or even a third-party hypervisor running your entire fabric, you could switch that over to Server 2016 Data Center Edition and configure it as a guarded fabric. You can switch between the attestation modes at any point of your choosing, but obviously you would need to have upgraded all of the hardware beneath all of the Hyper-V hosts to hardware that supports TPM v2. Most vendors already have models that contain TPM v2 by default. The only concern that we really have is for people with hundreds of machines and existing fabrics, we wanted to provide some way of dipping your toe in the water, so to speak, of a guarded fabric, and you can get some of the benefits using this Active Directory attestation mode, which is compatible with your existing hardware, and then piecemeal you can upgrade each of the hosts. Once all of the hosts have TPM v2, you switch the mode. Verify that it works. If it does work, great. Tear down the Active Directory trust, which is a prerequisite when using Active Directory attestation mode, and you've now invalidated that particular mode of attestation, and now only TPM attestation functions. All right, so hosting a shielded VM then. Let's just take a look at our laundry list here. The tenant first provides data necessary to provision a shielded virtual machine. This is referred to as shielding data, and we'll show you how to create that in a second, and we'll also show you what it actually contains and why it exists. So a shielded VM is then created on a guarded host, and this shielding data is injected into the virtual machine. It contains certain stuff that you think is probably important, like a password, or an RDP certificate to mutually authenticate a connection to a shielded virtual machine. But it can also contain things like an unattend file or other arbitrary files that you wish to securely install onto the virtual machine once it's been provisioned. Before a shielded VM can start, a guarded host has to provide a claim of health to the Host Guardian service. This is what we refer to as the health certificate there in step 3. In step 4, the Host Guardian service validates that claim by making sure that the health certificate was issued by it and it's not yet expired. The default health certificate lifetime is only 8 hours, so obviously it's sort of along the same sort of timelines as a Kerberos ticket there. The possession of that health certificate, it's a form of a claim or an authorization step that allows the Host Guardian Services key protection component to release keys. Number 5, HGS releases those keys. There's that key protection component again. And last but not least, the shielded virtual machine starts and is ready for use by the tenant owner. Now, when that shielded VM boots, obviously it has a synthetic or VTPM inside it. That VTPM actually allows the shielded virtual machine to leverage capabilities in the same way that physical machines with TPMs do. So it can use BitLocker. It can use UEFI, Secure Measured Boot. All of those capabilities are now available to a virtual machine running on Windows Server 2016 Data Center Edition inside a guarded fabric. All right, shifting gears for a second. Who are the personas involved in deploying a guarded fabric? Because we've sort of been flip-flopping between different people. So we've given them little icons here so that you can see where they're relevant later. The first one is the fabric admin. A fabric admin is the guy that manages the Hyper-V fabric itself. They manage the host. They may well even deploy the hosts. They may well configure the code integrity policy. And they're going to be the guys that add additional nodes when scale-out sort of services are required. The HGS administrator. This is a very, very simple role. It doesn't require day-to-day administration. It's really there for the initial configuration and setup of all of the things that constitute a Host Guardian Service cluster. Things such as signing certificates, encryption certificates, and the inventory database that contains the identities of the Hyper-V hosts that are trustworthy, the code integrity policy, and that TCG log, that baseline that dictates a Hyper-V host is indeed healthy if it booted like this. Last but not least, we have a tenant administrator. Tenant admins, these are the guys that own the virtual machine itself that runs on the guarded fabric. If this is an enterprise deployment of a guarded fabric, in all likelihood, the tenant administrator is just an employee within the organization and they're just a VM owner. The HGS and the fabric administrator may well end up being the same person. This is not what we would consider to be a best practice, but it is likely if the reason to deploy a guarded fabric is for compliance purposes alone. If, however, security is really the goal and compliance is just a side effect, then the HGS administrator and the fabric administrator must be separated. We have to ensure that separation of duty exists in order to preserve the security in the guarded fabric model. So let's go ahead and build a guarded fabric, literally step-by-step deployment from the ground up so that you can get to see how this is done. And rather than do so with Active Directory-based attestation, we'll do the more configuration-heavy TPM-based attestation, which lands us in our best practice model of TPM-backed attestation. So, step number one is to set up the host guardian service. Now, the basic way in which this is done is you add the HGS server role. You can do that through Server Manager or PowerShell. There are then two commandlets that you need to run. One is install HGS server. This is there to allow you to configure the Active Directory domain that's used by the host guardian service. And it can also do things such as leverage existing bastion forests if you happen to have one. And then last but not least, you need to run the initialize HGS server commandlet. So at this point, I'll hand it over to Ryan, who's actually going to go ahead and show you how these commandlets run and how you install the role.
Thank you, Dean. So if you look here on my screen, I have set up a host guardian service cluster. We're setting up the very first node in that cluster. And I've opened PowerShell here just to show you that I've already installed the host guardian service Windows feature. So as Dean said, the next step is to go ahead and run install HGS server. Now this command is all about preparing some of the prerequisites for the host guardian service, specifically the Active Directory domain, which it uses to control the identity and accounts used in the host guardian service cluster. So I'm just going to give a name here. I'm going to use secure.contoso.com, and I'm going to tell it to restart the computer afterwards. It's going to ask me for a safe mode administrator password. That's just standard Active Directory materials, and it will go ahead and set up the server. Now, the server I'm using here is already set up, so it finished immediately. Normally, this would just go ahead, take some time, and restart. Once you've set up your HGS server, now you get to initialize it. And this is the stage where you're going to specify three important details to the host guardian service. The first one is, what is the attestation mode you're choosing? Now, you can change that later on, but initially you have to pick if you're going to be working with TPM attestation or Active Directory attestation. After that, you're going to pick an encryption and signing certificate. These are two files which can be issued by your certificate authority in your company, and those control access to who can run VMs. So when you have a tenant that's going to go ahead and say, I want to be able to run my VM on your guarded fabric, they get the public keys from these certificates. You hold the private keys and store them securely on the host guardian service, and they're used to actually allow the shielded VMs to start up. So I've already set up two certificates here. So now I'm going to go ahead and run the initialize HGS server command. First, I'm going to go ahead and get the password for my certificates. I'm just going to go here, read host as secure string. Great. And now I'm going to run initialize HGS server. First thing I'm going to provide HGS service name. That's just the DNS name for the cluster as a whole. So you can access any of the nodes in the cluster just using this HGS. It'll set up round robin automatically so that you can go and make sure that each of your three HGS servers is being reached by your hosts. Next one, I'm going to provide the encryption certificate path. I already set that up here in C certificates encryption. I'm going to give it the password. And I'm going to do the same thing for signing. So these are two different certificates, cleverly named for their intended purposes. And lastly, what mode of attestation am I going to use? We're going to use TPM attestation. If I can go ahead and run that, this takes just a few seconds to complete. And once this is done, the entire HDS cluster is ready for your use, and we get to start configuring each of the hosts' attestation artifacts.
Great, thank you. So at this point, Ryan could also go ahead and start adding the secondary and the tertiary nodes if he wanted to make sure that the cluster had high availability. The syntax is effectively almost exactly the same. There's just a couple of tweaks on the install HDS server commandlet, and obviously the initialize HDS server commandlet is going to inherit some of the configuration from that which has already been deployed. Now you'll notice here I've got a step 1.5 rather strangely. What this is it's a somewhat optional configuration step, at least in regard to it being manual. It's typically configured by the Fabric Manager, typically System Center Virtual Machine Manager, but you can configure it manually on each and every Hyper-V host using PowerShell, and the syntax is shown on screen below. The next step, now that we've got at least a basic Host Guardian service, is to teach it how to measure which identities are permitted to run shielded VMs. This is that EKPub or endorsement key that I mentioned earlier on. We've also got to teach it what does a good boot look like, i.e. take a good golden image of a blessed Hyper-V host running Windows Server 2016 Data Center Edition, and we need to extract its TCG log, all the things that are measured about its boot path. And we need to copy those things over to the HDS server share. So before we go into that then, let's just take a look at this exact content here. You can see we've got a TPM readiness bullet point. This is basically saying, is the TPM owned for this purpose? So we have to capture that TPM and basically say, this is our TPM dedicated to the role of being a Hyper-V host. We then extract its endorsement key. There is a single PowerShell commandlet to do that. We copy the resulting file up to the HDS server's share, and that point in time, we have now identified just that single Hyper-V host. So to be crystal clear here, this step needs to be performed on every single one of your guarded fabric Hyper-V hosts. So if you had 1,000 Hyper-V hosts running your guarded fabric that could run tens of thousands of shielded virtual machines, you would need to extract the endorsement key public, or EKPub, from every single one of those hosts. So again, at this point, let me hand it over to Ryan, who's going to walk you through how it is we capture that platform identifier.
Great, thanks, Dean. So now I'm signed on to one of our guarded hosts here. We're already updated it with all the latest Windows updates and driver updates, so it's in that perfect state that we know we trust and are ready to take measurements from. So the first thing is the endorsement key. So I'm going to go ahead and get that here with this command called get platform identifier. The only parameter you have to provide to this one is name, and that is a identifier which you can use to help reverse look up machines on the HDS server to say, what exactly is this machine that I've authorized to run shielded VMs? So this would be a good place to use like a hardware or data center identifier, which can help you find that exact node in your server rack. So I'm just going to call this my server 01. Great. And then next, I'm just going to go ahead and save this into a temporary directory. Great, and that's it. So now that we have this file, we need to go copy that over to the Host Guardian service. So I'm going to go ahead and do that now. All right, so now we're on the Host Guardian service computer. I've copied over that platform identifier. I'm going to go ahead and run the command add HGS attestation TPM host. And the only thing I'm going to give it is the path to that file, so ctemp platform ID. And I'm going to go ahead and push OK. And we'll see here I got an error this time. That's telling us that the TPM, which was used on the guarded host, was not created with an endorsement key certificate. And that's a certificate issued by the vendor who creates the TPM to assert its authenticity. And some of the early models of TPM versions 2 just don't have this feature yet. So if you don't have it, you can just go ahead and acknowledge that you know this is a trustworthy TPM. So great. Now we have that added. I can go check here, get HGS attestation TPM host, and we'll see that my server 01 is registered on this machine.
Excellent. All right, so we showed you what this was about, this EKPub. It was about getting an identity for a TPM trusted attestation Hyper-V host. Ryan showed you how to extract it using PowerShell, how to push it out to a file, copy it over to the Host Guardian service, and then effectively, for want of a better phrase, he ingested it so that the Host Guardian service says, yep, I trust that particular EKPub. That's step 1 of 3, remember. So let's move on then. Now, the next thing that we need is this TCG log. It's the UEFI, Secure Measured Boot log, which is often referred to as the TCG log. We commonly refer to it as a hardware baseline. This is where you're capturing that UEFI artifact we mentioned earlier, the TCG log. It contains a number of things inside there. It's got UEFI keys, it's got these things called DB and DBX and launch authorities. This is just a UEFI variable that contains code signing certificates that are either blessed, the DB variable, or DBX. They are not blessed, they are excluded. Whitelist versus blacklist. All of these things constitute the TCG log. Now, how many of these baselines or TCG logs do you actually need? Well, with the EKPub, you needed one EKPub for every single host. In the case of the baselines, if you're using the same model, the same manufacturer of hardware throughout your entire guarded fabric, then you need precisely one baseline. If, however, you prefer the model where you don't put all your eggs in one basket and you've got maybe two different models from two different vendors, then you need as many baselines as you have different models of machine. So with that, let's show you how it is we extract this baseline, this TCG log, push it up to the host guardian service and ingest it. So over to Ryan.
Great, thanks, Dean. So now we're back on the guarded Hyper-V host, and we're going to go ahead and capture that TCG log. So to do that, we're going to run this command, get HGS attestation baseline policy. And this one's nice and simple. Just give it a path, ctemp, and again, this is created based on the type of server you have. So I'm just going to call this server model A. And that's a TCG log. So saw a few errors here. This is simply warning you, hey, in the current state of your computer right now, you're not going to be able to pass attestation. So this is a preemptive check to say, we know that you're not going to be able to run a shielded VM on this computer. And since we're just setting this up quickly right now, we can go ahead and say, we know we're going to go ahead and get that fixed before we actually start running shielded VMs on here. So I went ahead here and said, let's skip the validation. So just like before, we're going to go ahead and copy that file, server model A TCG log, over to the host guardian service, drop that in a temp folder. And again, we're going to run on the HGS server, add HGS attestation TPM policy. Give it a path. That is, again, going to be in our temp folder. And the name here is, again, just a friendly name to help you recognize what this is. I'm just going to call it server model A. Great. So you'll see it's enabled, successfully registered. Now, any machine in our data center that has that software, firmware configuration will be able to use that baseline and successfully attest.
Great, thank you. All right, moving swiftly on then. This is the final piece of information that we need to capture from the Hyper-V host in order to have enough data to make a decision as to whether a Hyper-V host is healthy or unhealthy. So that last piece is called the Code Integrity Policy. Obviously, I keep referencing this as HVCI, or Hypervisor-enforced Code Integrity Policy. That is merely the manner by which the policy is enforced. It's still referred to as a CI or a config CI policy. So what do these CI policies do? Well, the first thing they do is they allow you to decide which drivers, which DLLs, which executables, which binaries, which management tools, which utilities, which trickery. It basically allows you to author a very strong policy that says what an admin can do once the host has been booted in terms of which drivers, DLLs, executables they're permitted to run. If you do update the machine, it is necessary to update the CI policy. You may well add a rollup package, or you may well go ahead and add a different management tool. You will need to upgrade the code integrity policy to ensure that it's permitted. What about how many CI policies you need? This pretty much falls in line with the earlier statement that we made around the baseline. If you needed one baseline, in all likelihood, you'll need only one CI policy. There could be other reasons that would influence you where certain Hyper-V hosts have a certain additional set of tools, but for the majority of cases, you will need precisely the same number of CI policies as you need baselines. So Ryan's going to go ahead and show you how it is we capture that CI policy and how it is we upload it to HGS, ingest it, same old thing.
Great, thank you. So back on the guarded host here, we're going to run this command new CI policy, and that is how we actually go ahead and create the first code integrity policy based on the current state of this machine. So before you run this command, you have to make sure the software is just as you want, especially if you're going to create what is called an enforced policy, meaning that attempts to write or run software which you did not authorize will fail. So very important that the system is exactly how you want it before you run this command. Start off, give it a file path. We're going to go here, ctemp, CI policy.xml. And then here we're going to select the level. And the level specifies how specific do we want this policy to be. So the weakest level is file name. That's simply writing a big list of each of the files on this computer and saying, we expect there to be files in this location. If they're there, we can run those files. Now, we don't recommend that for guarded hosts because we care a lot about the security that we've built into Hyper-V 2016, and we want to make sure that's not circumvented by another program, which potentially could have the same file name. So we recommend using the file publisher policy. And that says that we're going to go evaluate all the files on this system and check which software company signed the file, and we're going to keep a log of that information. So all the files that come with Windows are signed by Microsoft, and that means that we're going to make sure that the files, when they're run, are still signed by Microsoft. They can be updated over time through Windows Update or other means as long as it's still signed by Microsoft. That will keep it compliant with the policy. And for those files which are not covered by the file publisher policies, that is maybe files from your own IT department which aren't actually signed, we're going to have a fallback here. And for that, we recommend hash, and that is simply taking a bit-for-bit analysis of the file and saying, this file can never change. If it does, we're going to have to write a new CI policy, merge in those changes to allow both options here. And as you can tell, these are very configurable, so if you decide that these are perhaps too strict or even too loose for your specific environment, you have full control over how these code integrity policies are created. So if we go ahead and run this, as the screen says, this does take a little while to do. It's scanning every single file on your computer to create this policy. I've gone ahead already and created the CI policy that we're going to use for the rest of the demo. So I'm just going to go ahead and bail out of this. Once you have that XML file, there's one additional step you have to take, and that is convert from CI policy. The XML representation of a policy is one that you can keep around and modify over time as you apply updates to your systems and install new software. The policy which Windows is going to need to enforce, and the one that the host guardian service wants to keep a record of, is actually in a P7B file format. So on this one, we would do something like binary file path ctemp ci policy.xml, or sorry, that's the XML file path. And then we would do binary file path ctemp ci policy.p7b. So as you can see by the autocomplete there, I've already created the P7B file, so we're going to go ahead and use this and register that with the host guardian service. So I'm going to copy that over to the host guardian service node. And now on HGS, we're going to go ahead and run add HGS attestation CI policy. Again, we're going to give it a path, ctemp CI policy, give it a name. Again, this is the kind of thing you want to make sure you name well so that when you're looking at HGS, you can go back in time and say, all right, that's a CI policy I wrote maybe a year ago. We don't trust that software anymore. We want to make sure our hosts are running more updated software. Let's disable that policy so that hosts have to run a newer policy. So I'm just going to call this CI policy 1. Great. So you'll see that policy was added and enabled. And at this point in time, we've added all 3 pieces we need to the host guardian service for this host to successfully attest.
Fantastic. Thank you very much. All right, so at this point, why don't we go back and just review those steps one more time. So there was a step 0 here, if you will, which is upgrading all of the guarded hosts, or well, I suppose they started as non-guarded hosts, they ended up as guarded hosts, to Windows Server 2016 Data Center Edition. That's step 0. Then we did step 1, which was to set up the host guardian service, where Ryan walked you through the install HGS server commandlet, where we created the Active Directory forest, the secure one, or we leveraged an existing Bastion forest. Next, Ryan showed you how to run initialize HGS server commandlet, where he dictated what the attestation mode was, at least the mode we begin with, and then the encryption and signing certificates necessary to authorize Hyper-V hosts to run shielded virtual machines within this guarded fabric. Then we went ahead and got the platform identifier. Remember, this is the EK pub. It is that endorsement key from the TPM on the Hyper-V host, the TPM version 2. We copy that endorsement key file over to the HGS server's share, and then we ingest it. And as I mentioned earlier on, you need one endorsement key or one EKPub file for each of the Hyper-V hosts. Third, we took a baseline, i.e. this is where we extract that TCG log, that UEFI secure measured boot log, and we upload those contents to the HGS service, and we ingest them again using the PowerShell line that Brian showed you earlier on. In terms of how many baselines do you need, it's not the same as the EKPub. With the EKPubs, you need one for every single host because they're all unique. With the hardware baseline, assuming you had only one model from one manufacturer, then you need precisely one baseline. If you've got two different models, same manufacturer, you probably need two. If you've got different vendors in there, then you certainly need a secondary one at the least. Last but not least, we generate that code integrity policy by taking a look, an image, if you like, of what's on the box. That was the part where Ryan said it takes a while to scan the whole thing. That got spewed out into an XML file. We converted or compiled that into a P7B, a binary format, which we uploaded and ingested on the Host Guardian service. At this point, you're actually done. The Host Guardian service itself and the Hyper-V host are now fully configured. You could deploy a shielded VM, but of course you need some additional configuration artifacts to go ahead and do that. So at this point, we'll walk you through that secondary piece, a step-by-step config of the shielded templates, the shielding data, and then right the way through to deploying that very first shielded virtual machine on your guarded fabric. So first off, generate a signed template disk. What exactly is this? Well, in any fabric, you have this notion of a template disk. In Windows terminology, it's typically a nicely installed, trustworthy copy of Windows with all the configuration and admin tooling on it that you deem to be necessary, that has been sysprepped and shut down. It is waiting to be given to a templating engine whereby it can be copied out, specialized, and then that creates a brand new instantiation of a virtual machine based upon that copied template disk. It has a unique name, unique SIDs, security identifiers, unique passwords, all of those good things. In the case of a guarded fabric, a template disk is an obvious attack vector. A malicious admin or malware could locate the repository of template disks and pre-install malware on those template disks, such that when you deployed a shielded VM that's enacting all these fantastic protections, it doesn't matter because the malware was already installed because it was present on the template disk. So a trustworthy administrator, either the fabric admin themselves or the tenant, the virtual machine owner, needs to create a signature at a point in time where that template disk is deemed to be trustworthy. So what I'm going to do right now is I'm going to have Ryan show you exactly how it is we create that signature and how it is we feed it into the whole guarded fabric workflow.
Great. So now I'm signed on to an admin workstation. So this isn't the Host Guardian service or a guarded host. This is just a standard Windows 10 machine that we've installed the remote server administrator tools on. And I've opened now the shielded template disk creation wizard. This comes with RSAT, and it helps us create that signed template disk. Before we can use it, we will have already had to create a sysprepped template disk that has our OS installed. So right now we only support Windows Server 2012 and higher, and that's because we require the UEFI secure boot in shielded VMs. So as long as you've got that installed on a VHDX file, we can go ahead and run it through this wizard to convert it from a standard template disk into a signed template disk. So the first page here we're looking at, that is asking us to identify the signing certificate. And this is the certificate used to say, hey, this is what we've signed and verified that we trust the current state of this template disk in. So I already had a certificate available on my machine called Contoso Template Disk. I'm going to go ahead and use that. This is something that would normally be created and issued by the hosting service provider. Next, we're going to go ahead and select that template disk. So on my SAN here, I've got a pile of template disks. I'm going to go ahead and take this Nano Internet Information Services disk image and turn that into a signed template disk. And this wizard will overwrite the disk, so if you only have one copy of it, definitely make a copy beforehand. Next page asking us about the disk name and version. So these are two things that provide a friendly name that the tenant or the person deploying the shielded VM is going to be able to look at and identify what exactly am I deploying. So for us, that's Nano IIS, and the version number, this is our first time, so we'll just call it 1.0.0.0. And we'll see later on that tenants can actually decide, do I allow my hoster to update template disks and should my shielding data work on future updated versions of template disks? That's where that version number comes in. So that's it, simply 3 questions, and we're going to go ahead and click Generate. And this part takes just a little bit to complete. As you can see, it first has to go and enable BitLocker on the template disk if it wasn't already enabled. Once it's there, it's going to go ahead and take a hash of the entire disk. We want to make sure that we know the state of the disk and can reevaluate that when we deploy the shielded VM. We don't want someone to go in afterwards and try to add malware to the disk. We'll evaluate that every single time we create a shielded VM. And once that completes, we can go ahead and take that signed template disk, add it to our Fabric Manager like VMM, and make that available to our tenants for their use.
Great, thank you very much, Ryan. All right, so quick review then. Ryan was generating the signed template disk there, sometimes referred to as a shielded template disk as well. The purpose behind this was to mitigate an attack vector, the attack vector where a malicious admin or malware running on a host that somehow managed to get there has attempted to infect the template disk with malware of its own or a rootkit, such that even when you deployed a shielded VM from this shielded or signed template disk, it didn't matter, the protections were meaningless, the malware had already been installed. Signed template disks mitigate that threat. So let's take a quick segue. What is a guardian? If you remember when Ryan initialized the HGS server earlier on in the demonstration, he had to supply encryption and signing certificates. This is effectively a cryptographic representation, a unique one, of a single instance of a host guardian service cluster. You could also say it's a cryptographic representation of a single guarded fabric. So a guardian is the term we use to describe the artifact that you extract from a host guardian service and you add to an authorization list on a shielded VM that says that shielded VM is permitted to run on that guarded fabric. What we're basically saying here is we have a mechanism built in to guarded fabrics that allows a shielded virtual machine to dictate which guarded fabrics, plural, it is able to run on. It may be just one, it may be 2, a disaster recovery fabric as well as an enterprise private cloud, or it could even be 3. At the point where shielded virtual machines become commonplace in the public cloud, you may well have an enterprise guarded fabric on premises, a DR, disaster recovery guarded fabric, at a different data center, and the ability to run your shielded VM in some public cloud providers' guarded fabric when they support shielded virtual machines. So, next step then. Create shielding data, otherwise known as PDK files, and then go ahead and deploy a shielded VM. Let's define a little bit what they're about. If you can imagine deploying a regular virtual machine with Azure, for example, when you go through the deployment, it asks you certain questions that uniquely identify that virtual machine. Things such as its name, an administrator password. If we were to say that that's required when deploying a shielded virtual machine, then that would be an attack vector for the malware or for the malicious admin to extract the password from the web form when you deployed it. So think of shielding data as a means of solving that challenging problem. How do you deploy the secrets to the fabric such that an administrator or malware, in terms of their prying eyes, can't see those secrets? Secrets such as the shielded or signed template disk signatures that Ryan just showed you how to generate. Secrets such as the guardians that dictate which fabrics this shielded VM is permitted to run on. The administrator password. RDP certificates to ensure that when you RDP to the resulting shielded VM, the connection is authenticated mutually at both sides. That's what the certificate does. And obviously an unattend file that allows the machine to be specialized in any manner of your choosing. Last but not least, miscellaneous tenant files of your choosing. Effectively, think of that as like a WinZip package because you wanted X, Y, and Z files also deployed on the resulting VM. Ryan's going to now show you how it is we create shielding data and then tie all of these pieces together.
Great. So back on the admin workstation, again, this is something now that perhaps a tenant would be running in their own environment, not necessarily in the hoster's environment. We're going to go ahead and create a shielding data file. And the first thing we're going to do is pick a spot to save the file. So I'm just going to put that on my desktop. Shielding data for Nano. And the first question we're asked here is, what is this shielding data for? And this is an important distinction. We talk a lot about, in this session about creating a new shielded VM from a signed template disk. There is also a way in guarded fabrics to convert an existing VM, which is not shielded, into a shielded VM. And shielding data is required for both. However, the process is slightly different. So we're creating a brand new VM, so we're going to go ahead and select shielding data for shielded templates. Next up, we're asked about the security policy for the VM. Now there's two ways you can create a shielded VM. The first is shielded. That is the truly most secure option, which locks out many of the security options from the Hyper-V administrator. So this means that a virtual TPM is required on the machine. Any live migration traffic must be encrypted. Secure boot is required and enabled. None of these can be changed by the person managing the Hyper-V fabric. Now, encryption support is a little lesser mode. In shielded VMs, you can't actually look at the content of the VM. You can't use VM Connect. You can't use PowerShell Direct to manage it. It's all blocked out. If that's too much and perhaps you're running in an enterprise fabric and instead you really just want the compliance benefits of being able to encrypt the contents of a virtual machine, encryption supported is a lesser level of protection, which allows you to still deploy with these signed templates. You still get the benefits of the host attestation, but the Hyper-V console is available. You can use PowerShell Direct again, and some of the security settings are configurable. So we want the most secure option today, so we're going to go ahead and use shielded. Now the next page is asking us about the owners and guardians. So Dean briefly explained what a guardian is, and now we need to go and actually go ahead and specify these. So I'm going to start by going to Manage Local Guardians. Great, so we'll see here I already have a few guardians set up. I'm going to go ahead and create a new one and import one for the fabric, which we just set up. So the create stage is important for you as the owner of a shielded VM. We have this concept of an owner guardian, and that's the person who's actually able to disable shielding at a later time. So this is a set of keys which you as the tenant workload owner will keep on your premises and actually use to identify you as technically the person who owns this VM. So I'm going to go ahead and call this Ryan's owner guardian. And you can go ahead and use a certificate issued by a certificate authority. I'm just going to go create self-signed certificates for this example. That takes just a second to complete, and we're ready. The next step is to identify which fabrics are allowed to run your shielded VM. And to get that information, I'm going to head over to Windows Azure Pack, which was set up for this fabric. This is talking to Virtual Machine Manager, which knows about the host guardian service we just set up. If I go to the shielding data page, I'm able to go ahead and download guardian information. And this is just a simple XML file, which could be provided from your hosting service provider in any means, just on their website. But we're going to go ahead and use this tool. We'll see that's now downloaded in our downloads folder. And I'm going to go back here and import that information. So I'm going to browse to that file. We get a warning here saying that we set up this guarded fabric using self-signed certificates. You would not get this warning if it was a certificate issued by a well-trusted authority, as would be typical in a production deployment. And you get to see here quickly information about that guarded fabric which you're trusting. I'm going to go ahead and call this the Contoso guarded fabric. Great. So now we've got a few things here. I'm going to go ahead and select the owner. For me, that's the Ryan's owner guardian. You can only have one guardian here. And the list is short because these are limited to guardians which you have the private key for on your computer. And I'm going to go ahead and select all the fabrics which I trust to run this VM. For me, that's just the Contoso guarded fabric. Go ahead and click Next. Volume ID qualifiers refer to the template disks which you trust to deploy your shielded VM. So again, I'm going to go back to Windows Azure Pack, where I'm able to download catalog information for template disks configured on this fabric. You'll see here I have one for Nano Server, that's the image we just created, or one for the full client server GUI, which has the full user experience. I'm going to go ahead and select the Nano Server one and download that information. Heading back to the shielding data file, I'm going to go select that file, You'll see that information we've typed before, a nano server, template version, that's all the same. Go ahead, click OK, and click Next. Next, we have to provide information about how we can specialize this VM into what it's eventually going to become. So I'm going to go pick an unattend file, which I've already created. And this is containing some of the secrets about how to actually deploy this VM, such as the administrator password and information about how to secure remote management of this machine. So this is Nano Server I'm setting up, so I don't have to worry about remote desktop certificates, but I am going to add a WinRM SSL certificate, which means that when I go to manage this machine, I will get an assurance based on the certificate which is presented to me when I go to connect through it with PowerShell, that this is the exact machine I intend to manage. There's no man in the middle. And this is an important step regardless of which OS you're trying to connect to, because you want to make sure that when you actually go to manage it, someone hasn't set up a machine trying to mimic your actual tenant workload. So I'm going to go ahead and click Next and generate this file. Great, so now that's available on my desktop, I'm going to go ahead and upload this into Windows Azure Pack and use it to deploy a brand new shielded VM. So I'm going to click Upload down here, browse to that file which we just saved on the desktop, shielding data for Nano. I'm going to save it in my subscription for the Contoso Guarded Fabric, and we'll see that's now available for my use. So let's go ahead and make a VM. Let's go to New, Standalone Virtual Machine, from Gallery. Here we see there's a few different types of machines we can create. We have these Nano Server encrypted. This means that it is a signed template disk. Again, we can see that disk information here, and it has a shield icon to help indicate that this is a shielded template disk. When I click Next, I'm asked for two simple things. What is the name of this VM, and what is the shielding data I want to use for it? So I'm going to call this my VM 01. And the shielding data, I'm going to select that one I just uploaded for Nano Server. Connect it to a network. And you're done. Now, we're going to go, what's happening behind the scenes is Virtual Machine Manager is going to go send all this information, the template disk and the shielding data file, out to a guarded host that passed attestation, is able to run shielded VMs. On that machine, we're going to go ahead and start provisioning process. During that, we're going to go and put all those secrets from the shielding data file into the VM, like the admin password, let it set up Windows. We're going to re-encrypt the whole VM because we want to make sure that the encryption keys are unique for each single VM. And in a couple of minutes, the entire VM will be ready for our use.
Excellent. So the next step is probably the step that you're going to like the most, and there isn't one, which is why you're going to like it the most. That's absolutely it, from beginning to end. So if you like, we can go back and review exactly what that statement of what is a guarded fabric and see if it makes a bit more sense now. So the idea of a guarded fabric is it contains guarded hosts that are able to protect tenant workloads running on the virtual machines from inspection, theft, and tampering from either malware or malicious system administrators. Now, the basic setup here was upgrade the guarded hosts, deploy and configure a host guardian service, extract the artifacts from each of the Hyper-V hosts, their identity in the form of the EKPub, a baseline policy in the form of that TCG log, and then last but not least, their code integrity policy. That gives us a guarded fabric, but it can't run shielded virtual machines. The next step, set up a template disk and sign it, which is basically you saying, I'm trustworthy and I bless this disk as trustworthy. You then save that signature onto the file system. You then create shielding data, which Ryan just showed you, which contains all of the secrets for deploying a shielded virtual machine, including the disk signatures, which are permissible when actually using this shielding data. Last but not least, run through the Azure Pack or the VMM user experience or even a PowerShell commandlet experience and go ahead and deploy a shielded virtual machine. Now, in addition, there are a lot of additional pieces of collateral out there on the internet already. There are a number of news interviews where it might be me, it may be Ryan being interviewed, and a lot of Q&A going back and forth that talks about the underlying tidbits, the technical pieces that make this as secure as it is. In addition, there's a great deal of documentation that can be found at aka.ms/shielded VMs. Hope you enjoyed it. Thanks for watching.